kids, this is Miss Haley, and today we're going to talk a little bit about elastic potential energy and gravity. So, first things first, what is elastic potential energy? Now we've been talking a lot about potential energy as stored energy, but when we add the word elastic in front of it, what does that mean? Well, elastic potential energy is any energy that's going to be stored in an elastic material. Elastic material can mean a lot of things. Could be a rubber band, could be a bungee cord, could be a spring, or even a trampoline. So what is it that makes something elastic? If we think about that rubber band, you might go, yeah, I know a rubber band's elastic, and it's elastic because I can stretch it, and that makes it elastic. And you would be partially right. But think for just a second about Laffy Taffy. Laffy Taffy is something that can be stretched, but Laffy Taffy is not elastic. So what's the difference? When something is elastic, you can deform it, like stretch it or compress it, and it's going to return to its original shape. So if you think about your rubber band, when you're stretching it out, if you let go, it's going to go back to its original shape. Laffy Taffy, if you stretch it and let go, it's going to remain in the same shape that you pulled it out to. Now, some elastic materials can become permanently deformed and lose their shape if they're stretched or compressed too much. So if you think about a rubber band, if you continuously stretch it and you keep stretching it, eventually it's not going to be able to snap back to its original form. It's going to lose its elasticity. So what does being elastic have to do with energy? So I know that there's elastic potential energy stored in this rubber band right here. But how much energy is going to be stored in that rubber band? How do I know how much energy? The bottom line is that the more an elastic material is stretched, the more potential energy you are storing. So let's take a look at a question. In which of the following pictures is the elastic potential energy the greatest? A or B? If you chose B, you'd be correct because we've stretched it a lot more. Therefore, it's storing a lot more elastic potential energy. So let's talk about gravity for a little bit. We've talked about gravitational potential energy, and that's the energy that an object stores due to its position above the ground because it has that ability to fall. It also had a lot to do with weight. The more weight something has, the more GPE it's going to have, and height. So the more height an object has, the more GPE it's going to have. And that's just a review of what we've been talking about. So let's talk about gravity in general. Long time ago, there was a scientist and a philosopher named Aristotle. And Aristotle had this great idea about things falling. He said if he were to take a baseball and a marble, and he were to drop them, the baseball would obviously hit the ground first because it has more mass. It's bigger, it has more mass, it's going to fall faster. Unfortunately for Aristotle, he never actually tested his idea, so he turned out to be wrong. Quite a few years later came along Galileo Galilei, and there's a story that says that Galileo took two cannonballs to the top of the Leaning Tower of Pisa, and one cannonball was one mass and one cannonball was another mass. And he decided to drop them at the same exact time, and do you know what happened? He found that when he dropped those cannonballs at the same exact time, even though they were different masses, they hit the ground at the same exact moment. Now, of course, you don't believe me, so I'm going to give you a second just to find two things of different mass next to you and drop them and see what happens. Now, some of you might be saying, okay, I picked up my pencil and the piece of paper I'm writing on, and the pencil hit the ground, but the piece of paper just kind of floated slowly to the ground. And you'd be right, because here on Earth, our atmosphere is made up of air. And sometimes air gets in the way of things. The air was catching that piece of paper and providing a little bit of resistance that the pencil didn't have. But, to prove it to you, got a video clip here from the Apollo 15 moon landing where they're showing that Galileo was right.
Well, in my left hand I have a feather. In my right hand a hammer. I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Mr. Galileo was correct in his findings.
Now, in the video, there's no air. So both things are able to fall without air resistance. And you know that a hammer has a lot more mass than a feather. But they still hit at exactly the same time. So, when we're talking about gravity on Earth, it's always going to move things or accelerate them toward the Earth. You're never going to drop something and have it fall up. It's always going to move down, which, it's down to us, but it's actually moving toward the center of the Earth. Now, what happens when we combine these two ideas? What do you get when you take elastic potential energy and you add gravity? You get the crazy harebrained sport of bungee jumping. And here's a great video that shows you one of the world's highest bungee jumps. To be honest, that video scares me every time I watch it. Okay, well, this is the end of our segment. Feel free to go back and re-watch and take notes on anything you think you need to.